Okay, we're back, and now we want to do resistors in parallel. So um, it's kind of difficult to see on that diagram there what two resistors look like when they're in parallel. So it might be better if you were to go to the PowerPoints and then look at the picture that is now in the blue column. So on slide number 24, it says how to solve a two resistor parallel circuit. And so take a look at those two resistors. Notice that they're side by side. Alright, so I want you to go back to the FET, disconnect your circuit, disconnect your resistors, and this time take the two resistors. You might need to clear some space. And I'm going to put resistor number 1 on the top. And then I'm going to put resistor number 2 on the bottom so that they're parallel to each other. And then I'm going to take my wire and I'm going to connect them so that they are making a box. So that's going to be two resistors in parallel with each other when they're connected like that. Almost looks like a series circuit, but there's no battery in there yet. Okay, now on your scratch piece of paper, I'd like for you to calculate what would be the total resistance of two resistors in parallel. Okay, and you can either use slide number 23 on the notes or slide number 24. So let's just go to slide 23. On slide number 23, it says that when they're in parallel, 1 over the total resistance is equal to 1 over resistor 1 plus 1 over resistor 2. So we're going to so on your piece of paper, you're going to write down 1 over the total resistance equals 1 over, okay, what's resistor 1? 10. So 1 divided by 10 plus 1 divided by 20. Okay, now we need to actually calculate this. So what is 1 divided by 10? So that's going to be 0.1. Okay, what is 1 divided by 20? So that's going to be 0.05. Okay, now we need to add them together. So what's 0.1 plus 0.05? Okay, that'd be 0.15. That's not the answer. So what we've just calculated is 1 over the total resistance is equal to 0.15. So in order to find the total resistance, we're going to need to take that number, the 0.15, and flip it upside down. So I'm going to get my calculator here, and I'm going to take 1 divided by 0.15, and that's 6.6 repeating. And so let's go ahead and round it to two significant figures. So let's say that it's 6.7. So that the total resistance, when you take a 10 ohm and a 20 ohm resistor and you hook them up in parallel, it's going to turn out to be 6.7 ohms. Okay, so let's go back to the lab. So I'm sorry that I'm having to ping pong so much around. Okay, so we're going back up into the lab and we are on part 5, resistors in parallel. Our next step is to put the hook up the battery to it. Okay, so you could either use the picture that is in the lab, or you can use the picture that's in the notes, but see if you can now hook the battery into the circuit. So we don't want that ammeter, so I'm going to cut the ammeter out, and I'm just going to put it off to the side, so that my circuit should only have the battery and then the 2 resistors. Okay, now it doesn't make any difference whether you put the battery on the top or whether you put the battery underneath the 2 resistors. It's not going to make any difference. So I took my battery and I put it on top of the 2 resistors. So I've got the battery on the top, and then resistor number 1, and then resistor number 2. And then I get out some more wire and I hook it up. Okay, now I'm going to measure the voltage. So on your chart that is on the Microsoft Excel worksheet, you've got a red set of columns, a green set of columns, and then a purple set of columns. So you should have filled in for the red set of columns the measured resistance of resistor 1 is 10, the measured resistance for resistor number 2 is 20. Okay, and then under the total measured resistance, we really can't do anything, so just leave that one blank. But we can do the calculated one. So under the calculated box, put in that 6.7. That was the total resistance in parallel. So we could do that. Alright, now let's work on the purple set of boxes. And we're going to do the measured voltage for it. So we're going to grab the black probe and put it across resistor number 1, and then take the red one, put it on the other side, and we get a voltage of 9 volts. So for resistor number 1, the measured voltage is 9 volts. Okay, now do it for resistor number 2. And we get the same result. So the rule is going to be that when you've got resistors in parallel, the voltage is going to be the same everywhere in the circuit. Okay, so you should have a 9 volt and a 9 volt for the measured voltage for both resistor 1 and resistor 2. And then the total voltage down there at the bottom, don't put 18. Okay, so take the probe and put it across the battery, and you see it's still 9 volts. So it's 9 volts everywhere. So the voltage is the same everywhere in a parallel circuit. Notice that's different than the series circuit. The voltage changed in the series circuit. What was the same in the series circuit? It was the current. So guess what's going to happen? In the parallel circuit, it's going to be the current that's going to be different. So I'm going to pause the tape here, and then when we return, we're going to continue to discuss this.